Here's an amusing little number puzzle that I like to call it mirror image magic, and it's a real brain twister. It's one of those things that cannot possibly work, but it does. All it requires is a piece of paper and a pencil and a calculator, and that's about it. So here's how it begins. You start with any number, and I picked 1, 2, 3 up here, and then you flip it around. So you get 3, 2, 1 in our case. Okay, that's not hard, right? Then you do the subtraction. You subtract 3, 2, 1 from 1, 2, 3. So you subtract take the original number and subtract the mirror image of it. And in our case, we get minus 198. To make it easier, we're going to get rid of that minus sign. There's no reason to have it. The results will just come out plus or minus, doesn't really matter. And then we divide by 9. So we take 198 and we divide by 9 and we get 22. And no matter what number you use up here, it's always going to be a natural number. It's always going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's never going to have a fractional part to it. It's never going to have a decimal place. It works for short numbers. It works for long numbers. It's going to work whether the digits are even or odd. It's not going to matter if they're all even, all odd, one's even, one's odd. Just, it doesn't matter. And it's not going to matter how many digits there are. You can have from 1 digit up to, I don't know, 1 million digits. And it's always going to work for you. Okay, if I pick numbers at random and I divide by 9, most are going to have fractions. I mean, I took the number 1, I stick it in my calculator, divide by 9, I end up with 0.1111. I take the number 1, 2, 3, which we just were using, and I divide by 9, I get 13.666 repeating. I take this kind of odd number, 1006 divided by 9, I end up with 111.222. So how does subtracting the mirror image of this number make it divisible by 9? So here I did this example. I did the subtraction, divide by 9, I end up with 555. It's negative, but I removed the negative sign. But anyway, it's the whole number. It's a natural number. Okay, so let's look at an example where the first number, the first digit is odd and the last number is even, just for fun. So there's our number, we reverse it, we get 421, 124 minus 421 equals minus 297. Let's get rid of the minus sign, make it the absolute value, 297. Divide 297 by 9, we get 33, natural number. So okay, so first number odd, last number even, that works. How about if everything's even? So we'll take an even number all the way across, 246, take the reverse, the mirror image of it, 642. Do the subtraction, 246 minus 642 minus 396. Okay, get rid of the minus sign. Divide by 9 and we get 44. Again, we get a natural number. So let's look at a short number. Is this going to work for a really short number? And let's try the shortest number there is, 1. So you don't get any shorter than the number 1. We'll add a 0 to it because 0, 1 is the same as 1. 0, 1, and then we'll take the reverse of it, the mirror image of it, which is 1, 0. We'll do the subtraction, so 1 minus 10 equals minus 9. Get rid of the minus sign. 9 divided by 9 equals 1, and again, we have a natural number. So it works for even the very shortest number. How about a long number? Okay, well, what is my number here? 9,483,726,195. That's a pretty big number. That's bigger than the budget in the country, I think. Okay, so then we'll mirror it. We'll just flip it around. Do the subtraction. We take our original number minus the mirrored number, and we end up with 35674523346. It's already positive, so we just divide this result up here by 9. And we get 396383594 exactly. You can check me with a calculator. And once again, we have a natural number. So that's pretty wild, but I've got something even wilder. This works for any base number. You probably learned in grade school different bases, and I'll just do one example of that. But let's take base 8 because your Microsoft, if you have Microsoft Windows at home, the advanced calculator, there's a calculator in advanced setting. It has octal, so you can use base 8. You can just click on the octal, it'll do the math for you. Start with an octal number, 17. Mirror it, so we have 71. So we take our 1, 7 minus 7, 1, and we end with minus 5, 2. Now normally in base 10 this would be 5, 4, but this is base 8, so we end with 5, 2, base 8. We remove the negative sign, and here's this unusual step. If you're going to do a different base, what you need to do is you need to take the base, we're using base 8, and you need to subtract 1. So we get 7. 8 minus 1 is 7. So we're going to use 7 instead of 9. Now we divide that number we got up here, 52, and we divide it by the 7. So 52 divided by 7 equals 6 base 8. And again, we have a natural number even though we're using an unusual base. So this is easy. I mean, all you need is a calculator, piece of paper, and a pencil. You can try it yourself. The trick here is ask yourself, how can this possibly work? How can you possibly, just by mirroring an image, doing a subtraction, end up with creating a natural number out of any possible number? Anyway, I hope you find this amusing and interesting. Thanks for watching.